Hey, welcome everybody. Today I want to talk you through the GPU accelerated remoting future. For those who don't know me, my name is Benny Twitch, and I'm an MVP, CTP, the expert, so dealing with the big three when it comes to the underlying infrastructure, but also trying to play nicely with the other big three, the ones that provide the GPUs, which are Nvidia, I have an Nvidia shirt on today, and AMD and Intel. So who knows that Intel is creating GPUs? Ooh, okay, so who thinks that they build great GPUs? Really? Before we start digging into the details of what these three vendors are doing, first of all, everything that I share with you today, you can get that from the Team RGE white paper. So who of you has downloaded that already? So there is still some potential. Okay. So Ruben Sprout, Sean Bass and I, we created this white paper, the 3D graphics for virtual desktop SmackDown. So for those of you who know Ruben, he's the one who drives all these SmackDown white papers, and so he inspired us to create yet another one together with him. Now, since Sean is CTO at VMware, he cannot contribute that much anymore, so maybe I should talk to the VMware folks and that they allow Sean to do more for the community than he does currently. Because
ask Sumit.
Oh yeah. VMware abuses Sean to win projects and win against Citrix and all of that. So it's interesting. But he's still one of the authors, so he's doing a lot of reviewing and stuff like that. So if you want to download the white paper, it's 95 pages. It's completely free. Just go to the website teamrge.com. Register. All we do is collect the email address and your name. So because we want to make sure that not crazy people are sort of doing stupid things to our website. This is why we need to check if it's a valid email address. So that's all we do. Besides that, it's for free. And I mean, this may look familiar to you. Why do we want to use GPUs in remoting environments? And we started having this conversation earlier when we did this MVP session. And it's a question, is it only good for designers, or are there other people who can benefit from GPUs? And the designers, they want to have dedicated GPUs, to be very clear. They want to have their own GPU because this is what they're used to have on their local workstations. These workstations are extremely expensive machines. Typically they're in the range of 20,000 euro plus the licenses. So we found designer workplaces with licenses that go beyond the 100,000 euro limit, and this is amazing. So it's extremely expensive places. And the question is it going to be the future work model that these people are using only their workstations, or are there any other models? And I will share with you some of those models in a bit. For power users and knowledge workers, that you want to use the GPU sharing or API intercept technology, and because then you can share those GPUs that are available in remoting environments, while task workers, they're pretty good with only software rendered graphics. So this is numbers that VMware came up, Nvidia came up with. They did a survey how many users are out there that could benefit from this technology. And you see the designers, it's only a 25 million portion of the market. Now you would say 25 million, this is a huge amount of people. When you look at it from a Microsoft perspective, this is nothing, because they have 1.5 billion Windows instances out there. Everything that is below 100 million users, Microsoft doesn't care. Very simple. Because, well, they are like a retailer, like a large retailer chain that is all over the world. And if it is below a certain limit, it's not interesting for them. So what they do is they rely on their ecosystem to take care of that. So this is exactly the niche that Nvidia was very happily creating business. But suddenly with the 200 million and 400 million users that can benefit from shared GPUs, so you go beyond this 100 million user limit, and suddenly Microsoft and other vendors like Intel, also like a powerhouse, get very interested in that kind of market. Just to walk you through the terminology, so if you were working on bare metal with a GPU, so this is what we call direct map, software accelerated or software rendered graphics. You use a CPU and you emulate the GPU. This is not very efficient because GPUs have many cores. We're talking about hundreds or thousands of cores because computer graphics is very good for parallel algorithms. So if you have parallel algorithms, you want to have multiple cores. Now on a standard CPU, you have not more than 18 physical cores, while on a GPU you can have up to 2,000 physical cores. So this is the reason why a CPU can never be as fast and efficient as a GPU when it comes to rendering computer graphics. Simple as that. This is why CPU rendered graphics will never be as fast as a GPU accelerated graphics. So now we have shared GPU, GPU pass-through, and GPU virtualization. You see that I did not use the vGPU term here because vGPU is sort of overcommitted. Because Nvidia uses vGPU for their technology and Microsoft uses vGPU in the context of RemoteFX. When I started putting documentation together and referred to vGPU, then the Nvidia guys came and said, no, you can't use this term because we own it. And then Microsoft came and said, no, this is not true because we invented it first. So the Nvidia guys, they have a trademark on grid vGPU, while Microsoft uses RemoteFX vGPU. So I also try to be very specific on in which context I'm using the vGPU acronym. This GPU virtualization, it is based on that multiple users are sharing a GPU, but with a native driver that comes from the vendor, allowing you to use all graphics formats. While if you have some of the shared GPU things, this is not the same, not the same functionality because like Microsoft, they're using API intercept. So the driver they have in the hypervisor is responsible for taking care of the GPU, which is not the driver that is provided by the hardware vendor. So it cannot support all the features that come with the GPU. So you will never get the same feature set or the same compatibility with applications when you use API intercept as compared to using the native driver. This is a very fundamental difference between those technologies. GPU pass-through clearly is the most expensive way because you assign one GPU or multiple GPUs to a VM. If we look at how Microsoft presents that, you see they are using pretty much the same segments, but they're giving it different names. The software side of things, the device assignment, this is their word for pass-through. They're even using the Nvidia logo for that one. The virtualization, again, the Nvidia because they are referring to grid, and they call it para-virtualization, and using vGPU, this is an original Microsoft chart. So when they say vGPU, they are referring to RemoteFX vGPU. Now if you compare those, you see that there are different use cases for them, and what Microsoft did is they said very clearly, we only support these two flavors, software and the RemoteFX vGPU. Now if you attended the MVP session that we did about an hour ago, you'll already learn that Microsoft now extended it also to the pass-through. So this is just for you to know about the basics. If you compare what's available out there, you see that Citrix and VMware, they're supporting the full stack. All the different technologies are included there, not on the Microsoft side. So Microsoft does only have this API intercept as of today. In the future, starting on Azure with the N series of VMs, they will have the dedicated GPUs or the pass-through. Good. What are the newest developments? When we look at, like I said, Nvidia, AMD, and Intel. So, Nvidia has the Grid technology. I will walk you through that. And the newest cards that they have for Grid version 2 is the Tesla cards. And they have what they call a software stack. So, that sounds weird for most of us, because if you look at Nvidia, we always thought that Nvidia sells hardware, GPUs, graphics cards. But now suddenly they decided that they are a software company. The question is always, why is that? Obviously the margins are a lot more attractive if you're selling software, and it is also better suited to change license prices in a more agile way. So it is very clearly that they want to get established in this software market, so they want to be regarded as a vendor for both hardware and software. So I will walk you through that in a minute. AMD, they came up with something. They announced it at VMworld in San Francisco, that they are working on something they call multi-user GPU, which uses SRIOV. It's a pure hardware stack, and you see there is on the Nvidia side dedicated VRAM and shared GPU, while on the AMD side it's dedicated VRAM and dedicated GPU. I'm going to explain that in detail in a little bit. Intel, they came up with the Intel Iris Pro graphics and what they call GVT. So it is an APU, so it's a CPU and a GPU on one single die. So it is like you buy a CPU, a processor, and what you get is a CPU and a GPU on the same socket. And this is a fundamentally different technology when you compare it to AMD and Nvidia, because they have to sell you a dedicated, discrete graphics card. So this is very different. And they built that into the Broadwell and Skywell lines of CPUs. Let's look at the Nvidia story first. You all know Grid V1. I think I presented it several times over here. I showed the comparison videos. So, like I said earlier, it is the idea that you have a shared GPU for multiple VMs, and you create profiles. The profiles define the amount of VRAM, the amount of video RAM, memory that is assigned to each individual VM. It does not give you dedicated access to GPU resources, which means when you do benchmarking and you only have one user on the system, even though you give him a profile that allows more users to use the same GPU, performance of the GPU compute will still be outstanding. The reason is this user uses the GPU exclusively. As soon as there are 4 or 8 users that have access to the same GPU because they also have that kind of profile, then suddenly it's a shared resource, and depending on what the other users do, the performance for the first user is degraded massively. This is something that many of our customers told us, that if they're doing initial benchmarks, they think, wow, this is outstanding performance, and as soon as they bring it in production, they are very disappointed because now suddenly the users are competing for compute power. And there's no fair share algorithm built into the software stack in V1. And this is the same thing for V2. There's not a real fair share algorithm that makes sure that one user gets a dedicated amount of compute resources. They're all competing for that. Now you need to know that GPU usage, no matter what you do, even if you're using design applications, is very bursty. So if users start doing the same thing at the same time, like in training environments, then it gets very painful, because if the trainer says, hey, now you're going to move this graphics from here to over there, and all the students are doing the same thing, so the GPU performance for all of them, the requirement for GPU compute power spikes up at the same time, and they're competing and they don't get the performance they want. So the GPU vendors like Nvidia, they were hoping it levels out. Sometimes it does in some environments when users are not doing exactly the same at the same time, but sometimes it just simply doesn't work. What Nvidia did with Grid V2, not only that they're using a new version of the GPU instead of the Kepler, now they're using, what is it? The Maxwell M, yeah. So it's the newest version. And the difference basically is that they have more cores for the M60, for example. So it's 2,000 cores per physical GPU. If you have 2 GPUs on one graphics card, that adds up to these 4,000 cores that you have available. That's a massive amount of cores. So this is why somebody said it's good for password cracking and everything. Yeah, absolutely. AMD and Nvidia GPUs are those, well, pieces of hardware that code crackers are using for their work. And I'm talking about professional code crackers, so not the hobbyists. Yeah, you can have a machine with 4 of these GPU cards in your basement and do some basic stuff. And you can use it for Bitcoin mining. So they're very well suited for Bitcoin mining. But we know about installations with thousands and thousands of these cards that do nothing else but cracking code. So Nvidia, they decided that now they want to sell not only the hardware and give away the software for free. They want to charge people for the software stack. Like I said, they want to be a member of the software vendor family. And I know that there's going to be a session tomorrow from Nvidia where they will walk you through the price model. It's a big risk for Nvidia because they are not selling the software stack themselves. They have deals with their OEM partners, so which means you will buy a server from HP, from Dell, that comes with 1 or 2 or 4 of these M60 cards. So you pay the price for the hardware first, and then they're going to charge you a license fee, depending on what your profiles are. And like I said, the trick is, and this is why it is a real software stack, you see here, there's this broker component, and this broker component lives in the hypervisor. So it is a kernel component, and it's responsible for assigning the resources to the individual VMs, like making sure that this VM only has access to a certain amount of VRAM. And this is why it has to live in the hypervisor. It basically really virtualizes the GPU, so the name vGPU is correct. So it's not misleading. But then it uses the graphics down here. Now this is how it basically works. This goes more into details because now you see that all these are Nvidia components. Those in purple, these are Nvidia components that live in DOM 0 or in the Citrix world and VMware world. It lives in DOM 0, so it lives in the parent partition of the hypervisor. So it really has influence on what's going on the machine. It creates an attack surface. And this is why Microsoft was so worried about using that kind of technology. So they decided we don't want anything that lives in this parent partition. So this is why for a long time they made sure that there is only a generic driver that comes from their hypervisor in each individual VM, nothing else. This is how the API intercept works. But this technology has been established over the last years. Citrix was the first, and then VMware also implemented it, and it's a success story, to be very, very clear. And now Nvidia tries to monetize on this success story, hoping that none of their competitors is able to come up with something that is good enough. Now the question is there going to be something that's good enough? This is again the Nvidia Grid 1 overview. You see all the different profiles that you can create with the Grid K1 and the Grid K2. The Grid K1 had 2 physical GPUs, high-end GPUs, while the Grid K2 had 4 low-end GPUs. It's more interesting to look at the newer models. You see here the two Maxwell Tesla M60. This is pretty similar to a K2 with two dedicated GPUs on the board, while the Tesla M6, it's more for laptop style. It's a different form factor. It's much smaller. So you can put it into very small servers. That's an interesting concept. Has anybody seen one of those cards? Like an M6? I've not. How big are they?
Very small.
Very small, okay, that size. Because they gave me an M60 at VMworld. They didn't know what to do with these cards after the show, and so they gave Ruben me one of these cards. They are expensive, like 5,000 euro or something, but there's no list price for them. Like I said, you can only buy them through an OEM model. And the Maxwell GPUs, and here are the Kepler GPUs, just to compare these things. You see there are more cores in the Teslas than there were on the Keplers. So that's pretty much the biggest difference. Here for blade servers, MXM. Like I said, I have none of these machines where I can test it. So this is what Nvidia does. Now what is AMD doing? About 2 years ago, they announced that they are working on a very cool technology, but they never were able to deliver. But now again, at VMworld, they had a demo environment at the booth. And for the first time, you were able to see the technology. So what they do is, they build everything around SR-IOV, and this is something that was used in the past, for example, to provide or to assign a physical network card to a VM. So we always ask ourselves, why is it not possible that you also assign a physical GPU to an individual VM? Because SR-IOV is a standardized way of doing it. So it's nothing that is specific to a vendor, neither on the hypervisor side, nor on the hardware vendor side. What happens is, they not only said, we want to assign one physical GPU to a VM, we want to be able to segment the physical GPU on a hardware level so that the machine believes that it's talking to 2, 4, 8, 15, 16 GPUs, even though there's only one there. Basically, the hardware is lying to the bus, to the PCI bus. This is what happens. So it's a hardware segmentation of the GPU. So it is baked into the physical graphics hardware, and it must be supported by the BIOS, because the BIOS needs to be able to deal with that many graphics cards. So if one physical graphics card pretends it's 16 graphics cards, and you plug in like 4 of those in a physical server, it's many graphics cards that are suddenly available on this system. And if the BIOS cannot deal with the sheer number of devices, you're stuck. This is why only the latest versions of the servers, like the Dell, it must be an R730. The R720 obviously does not support this technology anymore, because it's not enough memory range in order to support that many physical devices. So once the hypervisor becomes aware of it, it says, hey, now I have like so many GPUs, and I can assign those in a pass-through way to the individual VMs. So you install the native driver in the VMs, and it sees one of the GPUs, and it uses the GPUs. In reality, it's a shared resource. This is a very smart idea, because you don't have to modify the hypervisor. You're just doing pass-through. It's very simple, if AMD can deliver. And that is the biggest question that everybody is asking. Can they deliver, and what is the price going to be? Nobody knows that. So basically, it is static GPU partitioning, because they not only partition the video RAM, they also partition GPU compute, which means if it's really 16 different VMs that are using one physical GPU, So a user on the VM always gets only a 16th of the performance of the GPU, no matter what the other users do. So it's extremely predictable, no overcommit, never ever overcommit, both on the GPUs, of the compute side and on the RAM side. On the other side, if the other users are not doing anything, that one user cannot take advantage of these resources that are available. Okay, the question is, what will be accepted in the market if both technologies, Nvidia and AMD, will be out there?
So Benny, would this allow you to use Server 2012 with new hardware?
Nope. Server 2016.
It has to be 2016.
Yep. So it needs to be the latest versions. That is. I mean, the question is, are they going to be able to do that also for Server 2012 R2? Probably AMD could, if it's the newest server version with the newest BIOS. Will they support it officially? I don't know. Theoretically, it would be possible. I agree. But you see, it's not much in there. It's the GPU, it's this driver that lives in there. It's a standard driver that you need to put in the hypervisor, nothing tricky, and then it's only the AMD driver in each individual VM. End of story. No broker, nothing. Nothing complicated. Now looking at Intel, what are they doing? They come up with the Haswell CPUs with integrated GPUs. For a while you weren't able to buy it, except if you were HP. They had an exclusive deal with Intel, and it was using a moonshot implementation. That was the only way you were able to get access to that kind of GPUs in an Intel CPU, or if you bought a MacBook Pro. So that was the CPU that was built into the MacBook Pro. And some of you using, this is why you said it's good technology. So you were one of these these few ones who had access to this Iris Pro technology at a very early stage and found out, wow, performance is not bad, not at all. And but it was only for Apple and HP. It was exclusive contracts. I tried to get one of these CPUs from Intel. They said, no, we cannot deliver this CPU. You can't have it. And I was like, wow, this is interesting. And then they put the exact same technology into the newer ones, extended technology. What they also did very early, they built something that reminds you a lot of what Nvidia did. Also a broker that lives in the hypervisor, and they implemented it on Zen. So they were using the Iris Pro GPU and combined it with the Zen hypervisor, not Zen server, Zen hypervisor. And they gave it a name, and where is it? The graphics virtualization technology, Intel GVT. This is what they do when they're referring to this technology. The question is does it have any relevance out there? No, it actually doesn't. I think that Citrix now has a reference implementation running in their labs using this technology with Intel. But I don't think it will be very relevant because you can use these GPUs in a different way. Now the newer ones, they are supporting Zen Server, VMware vSphere, Horizon View. So these are the ones that come in a Broadwell CPU, and now you have 48 cores. Now just compare that to what Nvidia, the number of cores that Nvidia has. So it's not a high-end GPU. The question is, are 48 cores going to be good enough for smaller environments? And the beauty of that technology is it is pin compatible, which means Intel, they sent me a reference machine, and it came with a CPU that still had the GT2, which sucks from a performance perspective. It's far behind what you have on your laptop, what I had in my server. And I asked them, do you seriously want me to compare that to an Nvidia GPU? And they said, no, just keep the machine, we're going to send you something anytime soon. And suddenly I received a packet that came from Intel, and there was a CPU with no label. And I was like, what am I going to do with that? So I got in touch with the guys. I said, I have a CPU here that obviously came from you guys. Yeah, this is a prototype. It's unlabeled. Yes, officially it doesn't exist. Okay. So what do you want me to do? Yeah, you replace the existing CPU you have in your machine by this, and we got to send you a prototype BIOS. Aha. Now things get interesting. So you can just keep the machine that you have and replace the existing CPU, and certainly it has the GPU capacity in there. That is an interesting migration path. So no investment in a new machine, you just replace the CPU.
How many people are going to crack open their laptop and do that?
Not the laptops, the servers.
Oh, the servers.
It's for the server. It's server CPUs. We're talking here about the E-series, like so it is the server CPUs and not the workstation CPUs. There are interesting articles that you find now in the web because people who are specialized on the workstation side of things, they look at these CPUs and they say, what kind of crap is that? Who is ever going to use that? While the server guys never go to these websites because it's high-end graphics websites that are not doing nothing than dealing with this high-end graphics stuff. And typically server guys don't care about that, but I started reading these articles that these workstation guys got really confused and the server guys didn't know about that, so that was the interesting thing. What you can do with that, you can do anything. You can do the API intercept with it, the pass-through, you can do the GPU virtualization. It's good for all of those technologies that I've introduced earlier. So it is like a workhorse. Very cheap, not so powerful, but for many environments, just powerful enough. Probably for only 3, 4, 5 users per GPU, which is fine. So it's a little bit the moonshot on steroids.
And probably interesting for licensing also.
Oh, absolutely.
VMware.
Yeah.
It's no longer
It's agnostic. It's going to work with Microsoft, VMware, and Citrix. It just doesn't matter. It's completely agnostic. So now you have the situation that we have 3 different vendors that come with 3 fundamentally different concepts. Like Intel, from down, low end going up. Nvidia, high end trying to go down. And AMD trying to get in the middle and trying to survive. If they fail, if they run out of money, Nvidia's going to win. So this is going to be very interesting. Will they be able to deliver either this year or very early next year? Otherwise, they will. AMD is going to be out of business. And this is how these. Look at that. So there is a GPU on the die if you open it.
That's actual size, right?
Let's see. This is what you try to put into your laptop, exactly. And when you look at the architecture for the GVT, it looks exactly like what Nvidia did. So you have all these components in the DOM0, and you have the native driver in each VM, and this is the broker to assign the resources over here. And they only implemented it to make sure that their technology is compatible to that kind of architecture. Now, when I'm talking to the Intel guys, they don't have a dedicated department that deals with that kind of GPU remoting. So that brings you in that kind of situation. You have a conversation with one person and say, hey, this is interesting. I also learned from your colleague XYZ that you're working on that. And it's quiet on the other side. And then suddenly, can you send me his email address? And I was like, don't you know each other? Nope, it's the first time I hear about this colleague working on this. And they are very clear that they have never been very good at building complete environments. The server that I received and the BIOS, these prototype BIOS, man, what a piece of shit. It was so I was trying to install the BIOS, to update the BIOS. It worked the first time. They sent me a new one. It didn't work. I looked, and they had mixed up files in the file system in a way that it was impossible to install the BIOS. And I had to reshuffle all those files in the same way as it was in the first BIOS that they sent me. And then I got in touch with them and said, how in the world should a normal admin be able to do that if you do not have like an example of a BIOS that works? And their response was, yeah, we are not really good at that kind of stuff, because typically we just gave our CPUs to our OEM partners and they built the entire machine. Now if we have to build an entire machine, that's kind of a challenge. Okay, so if they're creating something like that, this is like a lab experiment. This is nothing that goes it's like mainstream. So this is the interesting thing that you learn about Intel. However, obviously they think this is going to generate a future revenue stream that is significant enough to invest into that. So if the sleeping giant wakes up internally, holy moly, they've got a lot of money. So this is what the differences are between those. This is what I wanted to share with you, just to give you an impression what's going on, and just to watch out what's happening. So sometimes you go to Wikipedia and just look at what Wikipedia has to say about the latest Intel CPUs, and you will see that sometimes these new versions of the CPUs show up, and you may want to search for these terms that I just presented here, so that you see what new articles come out. Because sometimes there is an article that explains some of this technology in a very good way, but there's no way you find it in the standard websites that you typically, that you typically use. This is what I found out. So you really have to know the word, the acronym, or the word for the term for the technology, and then you can start searching and you find interesting stuff. And sometimes they just announce stuff at one of the conferences and they do not, there's no press release or something. So you have to find something where a blogger is just blogging about this technology. So in particular when you look at the Intel stuff. So they really suck when it comes to their marketing and when it comes to organizing their internal teams. While Nvidia is spot on when it comes to that. At VMworld, Jensen, their CEO, he did the presentation. So it has this management awareness at Nvidia because they want to do the next step. The pricing is interesting. They were looking at the high-end workstations and thought, hey, this is the price for a high-end workstation. Now let's reduce the price by 20%. And this is still a high price tag. And start selling it to everybody out there. The thing is that nobody is going to buy a technology that's going to cost 15,000 euro per user. Yes, it's cheaper than buying a high-end workstation, but it's still a little bit out of scope for most of the users. So maybe they want to stay in this upper segment of the pyramid, which would open up a huge market for AMD and Intel if they're able to deliver. So this is going to be the interesting story. That's it. Thank you, folks.